All right, this looks like a problem you've done since, what, 5th grade? 6th grade, something like that? Okay, so obviously I'm not teaching you how to do this today. I'm teaching you how to do something different, but it's similar to this. And I want to be able to have a conversation about this before we go on. Are you okay with that? Okay, so how do you do this problem? Not what's the answer, what is the process of doing this problem? So we look at the first term here and we say how many times does this term go into that term? So what is it? 1, and where do we write that 1? Right above it, right? Now what do I do now? So I multiply, right? I multiply this number up here by this number over here, and what do I get? What is 1 times 3? 3, okay, good. Where do I write it? Underneath the 4. Now what? I subtract, okay? Answer this question for me. Is subtracting the same thing as adding the opposite? Yes? So, subtract. What do I get? 1. Okay, that took way too long. It's okay though, it's alright. Now what? Am I done? What do I do? No. I bring the 9 down, right? Now, do I bring the 9 and the 6 and the 3 down? Could I? I definitely could, right? Okay. But I know that 3 goes into 19, right? So I don't need to bring the rest down. How many times does 3 go into 19? 6. Okay, where do I put the 6? Above the 9. Now what action do I take? I multiply. 6 times 3. What is 6 times 3? 18. And then subtract, right? 1. Or add the opposite. Okay? Now what? Drag the 6 down. Now what? How many times does this number go into this number? How many times does 3 go into 16? 5. Where do I write the 5? Okay. And then action. Multiplication. What is 5 times 3? 15. I write it below here. Subtract. 1. And now bring down the 3. Now what? I divide, right? What's 13 divided by 3? 4. It goes in 4 times, right? So I write 4, and what do I do with the 4 and the 3? Multiply. 4 times 3 is 12. Write it here. Subtract. And I get 1. Now, if I was trying to figure out the exact answer, I would go to decimals. I'm not trying to do that. Okay? I'm done, and I need to write the answer. The answer is 1,654, and the remainder of 1 over, what was I originally dividing by? 3. Does that make sense? You guys know how to do this problem already, so when I say does that make sense, you should all say absolutely. Okay? But guys, we needed to have this conversation before we go to the actual problem for today's lesson, because this conversation that we're going to have is almost the same conversation as this. It just looks different. Okay? But this is what we're doing. What is this called? What is this called? Division. What kind of division? Long division. Okay? Just because it says long division, does that mean it's hard? No. We learned about that yesterday, right? It looked hard, but it was just a pattern and a puzzle. That's all it was yesterday, wasn't it? Okay? So let's look at this problem then. Isn't this the same kind of problem that we just did? Yes, it's a division problem. The only difference is it's polynomials. So let's set it up. Okay? Let's set it up. What goes where? So it goes underneath the division sign. Do you know the name for that? It has a name. I want you to look it up for tomorrow. Okay? 2x to the fourth, but I need you to be careful. So can you stop writing real fast and watch what I'm going to write? If I start with an x to the fourth, I need everything underneath it. Okay? What do I mean by everything underneath it? If I've got an x to the fourth, I need an x to the third. I need a x squared. I don't have one, but I need one. That's exactly right. I'm going to put a 0x squared. Why don't I just put an x squared? If I put an x squared, I've completely changed the problem because I'm adding an x squared of the value that I don't know yet. But if I add a 0x squared, I'm just adding a 0. That doesn't change the value of the problem, does it? Okay? So I need a 4, or if I start with the 4, I've got a 4, a 3, a 2 as my exponent, then I need a 1. Do I have one? It doesn't say a 1 though. Still, I have it, right? And then I need a constant. Anytime I don't have one of these, I put in a placeholder. I put in a 0x squared or a 0x or a 0x to the third. Whatever I don't have, I need, and I put in a placeholder. Does that make sense? Okay. What else goes where? The other goes in the front, right? So x squared plus 3x plus 2 goes in the front. Now, here's where it's just slightly different in our favor. Slightly different in our favor, okay? I don't divide this whole thing by this whole thing. I just divide this by this. That's it. Just the first term by the first term. What is 2x to the fourth divided by x squared? And what I mean by that is 2x to the fourth. I'm just reminding you of this. You already know it, but let me remind you. If I'm dividing like bases, what do I do with the exponents? I subtract. What is 4 minus 2? Excellent. So I end up with 2x squared. Got it? Now, so I said 2x to the fourth divided by x squared, and you told me the answer was 2x squared. Where do I write that? On top where? I want to write it above the term that it's like, over the 0x squared, okay? If you'll give me just a minute, I will explain why that's true. Is that fair? Not why it's true, but why we want to write it over the term that it's like. Does that make sense? Okay, so now what do? What did I do here when I got a number up here? I multiplied, right? Guess what I do here? What's 2x squared times x squared? 2x to the fourth, right? So 2x to the fourth. What is 2x squared times 3x? I have to multiply by everything over here, not just the first term. When I do my division, I just do the first term, but when I do my multiplication, I multiply everything. So what is 2x squared times 3x? 6x to the third, good. And what's 2x squared times 2? 4x squared. Okay, now what do? Subtract, right? Here's the thing about this, though, that I need you to be very careful of. Okay? If I subtract by putting a subtraction sign right there, how likely am I going to remember to subtract these two numbers? Very likely, because my subtraction sign is right there. How likely am I going to remember to subtract those two numbers? Maybe. How likely am I going to remember to subtract these two numbers? Probably not. It's so far away from the subtraction sign. So what if I subtract every number? If I subtract every number. When I go to subtract, whatever sign is there is going to be the opposite sign as it was before. In this case, they're all subtraction signs, right? But now I'm going to remember that I'm subtracting. Does that make sense? Okay. Now go ahead and do the subtraction. 2x to the fourth minus 2x to the fourth. Should that ever be anything but 0? No. I purposely set it up so that that would be 0, didn't I? Okay, so that's 0. What is 3x to the third minus 6x to the third? Negative 3x to the third. What's 0x squared minus 4x squared? 4x squared. Now what? Bring it down. Now on some of these problems, you're going to want to bring down everything that's left. Remember, I even asked you in this problem, could I go ahead and bring down all the other numbers? And you were like, you scoffed at me and you were like, oh, that's ridiculous. But you agreed with me that we could if we wanted to, right? Well, on these problems, we're going to want to. Okay? Just whatever's left, go ahead and just bring it down. Okay? And if you want to think about it this way, we are actually subtracting something from those numbers, just a 0. So I'm just 5x minus 0, negative 1 minus 0, so I'm just bringing those numbers down. Does that make sense? I say bringing down as if that's some sort of math term. It's not. We are in the action of subtracting, just like I did every term. Like over here, there's just zeros right there. So 5x minus 0 is 5x. Negative 1 minus 0 is just still negative 1. Does that make sense? Okay. Now what? Once we did the first row here, then what did we do? I brought the number down and then I started over again, didn't I? Okay. If I'm starting over again, I divide just the first term here by the first term here. What is negative 3x to the third divided by x squared? Negative 3x to the third divided by x squared. What do I do with like bases when I'm dividing like bases? What do I do with the exponents? Subtract. So negative 3x. Yeah, that's right. Where does it go? Where do I put negative 3x? Over the term that it's like, so I put it over the 5x. Okay? Now what do I do with the negative 3x? Multiply it times everything that's right there, don't I? Negative 3x times x squared, what do you get? Negative 3x to the third. Good. What's negative 3x times 3x? Good. Negative 9x squared. What's negative 3x times 2? Negative 6x. Now, here's the part that can be tricky if you let it, so don't let it. What do I do now? I'm subtracting, right? If I'm subtracting a negative, what's happening? I'm adding. If I'm subtracting a negative, what's happening? I'm adding. If I'm subtracting a negative, what's happening? I'm adding. So sometimes that can be confusing for people because up here I just wrote subtract, subtract, subtract. Well, those were all positive numbers, weren't they? If I'm subtracting a negative number already, I'm adding it. Now we're just combining our terms right here. Okay? What's negative 3x squared plus 3x squared? Or sorry, to the third. 0, right? What's negative 4x squared plus 9x squared? Very good. 5x squared. What is 5x and 6x? 11x. Very good. And then? Negative 1. Now what? Start all over again. Divide the first term here by the first term here. What is 5x squared divided by x squared? Do I need to write that one for you? 5x squared divided by x squared? 5, yeah, for sure. And again, it goes above the term that it's like. It's the constant, so it goes above the constant, right? Okay, now what? Multiply. What's 5 times x squared? 5x squared. What is 5 times 3x? 15x. What is 5 times 2? And now? Subtract, subtract, subtract. 5x squared minus 5x squared? 0. 11x minus 15x? Negative 4x. Negative 1 minus 10. Negative 11. Now what? You remember a second ago I told you if we're going to write the terms, when we do the division, we write the terms above the term that it's like? Here's the reason I like to do that. That's not a required thing. That's a Mrs. Kingston suggests you do that kind of thing. Okay? Guys, is there any more places to fill in? No, we're done, right? There's no more places to fill in. But if you think about it, can I do any more? Can I divide an x term by an x squared term? I can't, right? That x squared term is bigger. I can't divide that by that. Okay? I cannot divide this term by this term. But then again, I don't have any more places to fill in up here, so I know I'm done. So this is kind of a visual clue that this is that's the remainder. Okay? So when I go to write my answer, here's how I write my answer. I say my answer is 2x squared minus 3x plus 5. Remember how we did it on this other problem? Remember? This was our remainder, right? So plus my remainder, negative 4x minus 11 over what? What did I write it over on this problem? What we were originally dividing by. That's absolutely correct. X squared plus 3x plus 2. And that is my answer. So it's what I got when I did my division, right here, and then plus my remainder over what I was originally dividing by, because that doesn't ever simplify to a 0, so that is my fractional remainder. Okay? Any questions about this? If you look at it right now, does that look hard? Just looking at it right now, that's a whole bunch of stuff, isn't it? So people have a tendency to think that's hard. Was it hard when we went step by step? No. Okay? So be patient with yourself as you're going through these. Something that I need to remind you, I already told you once, but I'm going to remind you, when you go to write the problem, whatever your starting exponent is, make sure every exponent below that is there in your problem. Okay? If you started with an x to the fourth, make sure you have an x to the third and an x squared, even if there's not one written in the problem that you're given. Does that make sense? And then your x term and then your constant. Okay? Any questions?